see. So we're going to create a new project here for our unit tests. And we can just here search for unit test, and it will suggest a project of type unit tests.NET framework, which is the correct is it though? Yeah. It doesn't really matter. We're going to use a unit test project.NET framework and call it speedrun WCF.test and create it. There it is. There's already a unit test stub in there, but I'm going to delete that. And let's create a unit test class to test our game repository. We're going to do that by creating a new class. And we could use the unit test template, but it doesn't really do much. So we're just going to use the regular class and call it game repository test. Add. And now we don't need to make it public. Internal is perfectly fine. And we're going to need to decorate this class with the test class attribute, which is defined in a different namespace actually. So we're going to need a using directive to include that namespace. There we go. And now we're going to create a test method and call it getGames. Well, actually, let's use, whoops. Let's call it getGame and make it actually look for one specific game first. And we need to decorate this method with the test method attribute so that it is recognized as a unit test method. Okay. So that's that. Yeah. So now our unit test project needs a reference to our infrastructure project as well as the data project, because it needs to work with the database context as well as the repository, and it needs to know about the actual classes that describe our models. So let's add references to the other projects here, add reference, and simply select both of the other projects, hit OK, and that should be it. So now we can make it say using what was it called? Speedrun data models, using speedrun infrastructure repositories, and using speedrun infrastructure config. Whoops. Okay. Those should be all the namespaces that we need. Yep. Okay. So first of all, let's create the context, the database context. And for that, we just need to create an instance of speedrun database context. But there will be one problem. Our unit test project does not have a reference to entity core, the entity core framework. So it doesn't know about the types defined in that particular assembly. We do know about the speedrun database context class, but we don't know about its base class, the DB context. And that's why we can't actually call any of the many methods in the DB context class, which is a problem. Or actually, is it? Yes, it is. It is a problem. It will not be if we do one further step. But no, let's just simply go here and add a reference to Entity Framework Core, because at the end of the day, this is just a unit test assembly. It doesn't matter what dependency it has. It's just for testing. So we don't care about its dependencies. So we're going to install the same version in our unit test assembly. I mean, there's ways to not do that, but we'll just go the straightforward way. And I think I just lost my connection to the internet. Or did I? No, I didn't. Okay, there we go. Yes, we want to actually install all of these. I don't know why it's taking so long. Usually it doesn't, but I think my laptop is a little bit overwhelmed. And also install the SQL Server extensions. There we go. Yes, we want to install that. Yes, we accept. And this should be it. Okay, so now when we go back into our unit test class, here we can see that now our Speedrun database context object actually has all of its inherited methods. So we're good now. And actually, a database context, the database context class implements the iDisposable interface as well as the disposable pattern, which basically means that when you no longer need the object, you need to dispose of it, which frees all of the resources that it consumes. And one way to do that would be simply, as soon as you're done with the object, simply call the dispose method. That's one way. But to basically ensure that once a certain scope, once we're out of a certain scope, it is automatically disposed. We can use the using block and simply put the instantiation, the initialization here in the head of the using block. And now once the scope of this using block is left, the dispose method will automatically be called, which basically just closes the database connection and stuff like that. Yeah, so now we have an instance of our context, and with that we can actually create an instance of our game repository. And notice that in this case we actually declare it as the concrete type game repository, because there would be no point in using the interface, because we're going to actually instantiate a concrete game repository anyway, so this would not have any benefit, and it would just need, and I would just need to add another reference here, so we don't care about that. Okay, more coding, less talking. Okay, so now we have our game repository, and with that we can retrieve the game from the database. And we need to specify the ID of the game that we want to retrieve. We're going to use a local constant for that and call it, I don't know, target ID. And let's just say, let's return the second game. Oh, actually, we started with 100, right? 100 was Super Mario World and 101 was Super Metroid. So let's retrieve Super Metroid from the database. Okay, so we can just go game Super Metroid is game repository get item target ID. So now when we call our get item method of the repository, let's look at our definition again. We simply call the set method of the context, which will retrieve the entire set of games as a queryable collection, and then from that collection we will find the one with the target ID. So this should then return the game that we're looking for, and our unit test would not be complete without an assertion. So we need to actually call a method in the assert, in the static class assert, and well, what is the condition? What would be the condition for a successful test in this case? First of all, let's just say is true, and the test is successful if, first of all, we don't get null from the database, and also if the name contains Metroid, something like that. So if the game we get back is, the instance is not null, and also the name contains Metroid, obviously it's the correct game, so that means our test was successful. And to run this test, we can either just right click here and say debug tests, or go into the test explorer and select it from there. It's not shown here yet because I haven't actually built the solution. So let's say right click build, and I hope this builds without a problem. I hope we haven't overlooked anything, but it seems to be all right. It says 3 succeeded. We have exactly 3 assemblies to compile, and so that's good. So now let's actually put a breakpoint here and debug this test. Now, why doesn't it show up? Did I forget something? Hold on, I think it does. It needs to be public. Yeah, sorry about that. Of course, the unit test class needs to be public in order for the test explorer to find it. And here is our test method, and we're going to right click it and say debug. So now we're going into debug mode, and hopefully, if we've done everything correctly, we should get Super Metroid from the database. And let's look here in the debugger. Here, this is why I why I implemented the override for the toString method. So so basically just to pretty print the value of this object of type game. And as we can see, the game retrieved has ID 101, which is the ID we were looking for, and its name is Super Metroid. Publisher is Nintendo, blah 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 blah. So yeah, it's the correct game. We actually retrieved it from the database. Let's assert the condition, and it says it failed, which is probably because I messed something up in the condition. Yeah, this is when you do not prepare anything. Did I misspell Metroid or something in the database maybe? Oh, I said equals null. Well, that was stupid. Okay, so now if we run the test again, we don't need to debug, we just run it. It should actually succeed. There we go. That's a lot of green check marks. That's a good sign. Okay, so we successfully retrieved the game from the database. Let's do this exact same thing with the getGames method. I don't see a reason why this wouldn't work if this works, but yeah, let's just do it. Instantiate the game repository, and instead of just retrieving one game, we're going to retrieve all of them. Which means yep, and assert is true, games is not null, and games any. So the any method without is an extension method from the link namespace, and it without a parameter, without an argument, it just returns true if there's at least one element in the collection. So yeah, let's actually debug that as well, just to make sure. Games, here we have a list with 3 items, and these are the 3 items, and it seems to be alright. So we got Super Mario World, Super Metroid, and Final Fantasy VII. And I think I just pronounced that weirdly. Okay, so now we know that our database connection works, and we're able to retrieve items, objects from the database. So let's further build on that basis. Okay, so what are we going to do next? As I said, no script, completely impromptu, multiple cuts, edits probably because I had some bloopers and screwed up a few times, but who cares? Never mind. Okay, so let's see, what can we do? We're able to retrieve the games, but eventually our web service is for retrieving the speedrun records. The actual interesting part are the records in this table here, joined with both of the other tables so that we get the complete set of data. And yeah, so basically we want to have like a public interface where someone can send a request and they get like a complete list of speedruns that have been registered by certain players. So yeah, so that's what we want to achieve, and that's what we're going to achieve. So we don't actually need a repository for the player, not at this point. at least. What we need now is a repository for the speedrun object. So that's what we're going to implement. So here's the speedrun repository interface. Let's create an actual implementation of that in our infrastructure layer. So let's add a new class in the repository's namespace. Hold on a second. Okay, I just need to make sure from time to time that I'm still recording because, yeah, while this is a quite powerful laptop, there's a lot of stuff going on in the background, and yeah, I just want to make sure everything's all right. Okay, so new class, call it Speedrun repository. It's going to be public, and it's going to implement the iSpeedrun repository interface, which is in a different namespace. We're going to use IntelliSense in order to automatically add the using directive. And now we're going to use the quick action in IntelliSense to create an implementation stub for the interface. There it is. And as you can see, it will be the exact same implementation. Hold on, I forgot something. I know copy paste is generally a sign that you're doing something wrong, but we can refactor this later. This is just, we're trying to achieve, trying to do the job here, right? I mean, what we could do is have a generic repository with a type parameter, as I said earlier, and just basically make these concrete types here actually variable, and then we wouldn't need to implement this twice, so to speak. But since it's so frigging simple and so small, it doesn't really matter. Okay, so let's say set of speedrun find ID, and here we say it can't find the toList method because it's in the link namespace and we haven't included that, so we're going to do that. There it is. I mean, there's other ways to do that. We could have also... No, that would have been a bad idea. We could have created an array from the objects. But that's just the most convenient and simplest way to do that. Okay, actually I'm going to convert this into an expression body, an expression bodied method, and this as well, because I just prefer it. It's really just a matter of taste. There's no particular reason. It does semantically it's identical, it does the exact same thing, but it just looks nicer when it's all in one line. At least to me it does. Okay, so speedrun repository implemented successfully. Later on, or maybe in a future video, we're also going to have methods for inserting and updating speedruns, but for now all we need is to be able to retrieve them. Okay, so yeah, that is it. And I think we can actually get started with the actual web service. I think that's all we need. Oh, actually, no. There's another thing we need. We need the domain service layer of our application. I mean, you could argue that I'm over designing this with all of these different layers in a repository pattern, but this is for like educational purposes and demonstration purposes, right? And also it's for fun. Mostly it's for fun. So yeah, we're going to do it in a very elegant, clean way. So yeah, maybe not the most optimal, but whatever. Okay, add a new. We're going to add a new project, which will also be a library of the .NET Standard, and it's going to be called. Sorry for all this sniffing. I'm a little bit. I want to say I'm sick, but let's say I'm exhausted. Speedrun WCF dot service. For example, you could also call it like domain or application. No, not really. Application is not really a fitting name. Let's call it service. Service is fine. So this assembly, this project will basically encapsulate our business logic, so to speak, our domain logic. So it will, as the name service suggests, sorry, it will contain service classes, and so we will create another, a new class in this project called Speedrun service. And this is going to encapsulate domain logic. Yeah, it's going to look very simple. First of all, what I really like to do is I structure my classes or my code in general with region preprocessor directives like this, and basically create like a scaffold that looks like this. And then I'm going to put all my member declarations in the appropriate region. First of all, we're going to need a field of type what was it? Speedrun repository. And we need to add a reference to our data project, either using IntelliSense or by going here and actually add the reference. It doesn't matter. I'm going to use IntelliSense. There we go. Actually, this is going to be a read-only field. And this is going to be initialized in the constructor, of course. Otherwise, it would be completely pointless. And this is where our interface comes in handy, because now when we create an instance of our Speedrun service, we can inject a concrete implementation of this repository into the service using the constructor, which means that we can swap out the implementation at any point in time. We can just at one point we create the we instantiate the service passing the actual concrete implementation that connects to the database, and at another point we can just pass a mock-up implementation that just returns test data. Yeah, I don't know if we're going to do that actually, but for demonstration purposes, this is referred to as dependency injection and inversion of control. So basically, inversion of control in terms of it's no longer this the domain layer here that controls what concrete implementation is used. but it's determined by the application layer itself. So when we want to reuse our domain logic in a different application, we can actually pass like a different implementation of the repository that maybe connects to a MySQL database, or that just reads the data from, I don't know, giant JSON file, something like that, you know? Okay, I'll just explain it very briefly and quickly. I could talk about this for hours, but I'm not going to. Yeah. What is our speedrun service supposed to do? Actually, for now, we just want to retrieve the speedruns from the database. That's it. We haven't actually mapped the speedruns to the database yet, so we need to do that. Let's go here, config, and go into the speedrun database context. So far we only mapped the game, but we also need to map both of the other types actually, because both of the game and the player are components of the speedrun in an object-oriented context. So we need to retrieve both of them from the database. That's sorry, it's a bit late. Sorry. Okay. Speedrun entity. We're going to use the model builder to get an entity builder out of that of type for the type speedrun. There we go, and we're going to map it to the speedrun table. Then we're going to specify its primary key. The heck is wrong with my IntelliSense? Oops. And the key is actually the ID property, and I misspelled that. Then map all of the properties, which includes the ID. We map it to the column of the same name. And what else? Record date. And now that's an interesting part. Now we need to do a conversion, because our time property in our class is of type timespan, but the attribute in the database table is of type big int, which basically more or less translates to a long in C#. So that means we need to convert the value from one type to the other, and we do that the following way. Has conversion is a method here, and there's multiple overloads for that as far as I know. Yeah, there's 8 overloads of this method. Let's see, there should be one. So what's going on? Why is it closing all the time? There should be one that takes 2 delegates, I think. Pretty darn sure there's one that takes 2 delegates. Why is it? I don't know which argument is which. I don't know if this is the one that should convert the database value to the value here in C#, or it's the other way around. So that's why I would actually prefer to use IntelliSense, but it won't let me. Configures the property so that the property value is converted to and from the database. So to and from. So to the database is we get the ticks, and from the database is we get the value from the database and pass it to the static from ticks method of the time spent class. This should work. Pretty sure this works. And then this, we need to specify the column name, which is time. Actually, we don't need to do that since the attribute in the database table is called exactly the same as the property, but yeah, whatever. I'm just going to structure this more neatly. And there we go. This should be it for the time. Hold on. Do we have more properties than that? Okay. Yeah. Okay. So now that we mapped all of the properties in quotes, there's two more properties, of course, which is the player and the game, but those are actually navigation properties. They actually navigate to a different entity type, player and game respectively, and yeah, we need to tell entity, the entity framework that is, that our speedrun entity actually has a relationship, a one-to-many relationship to both of these other entities, and we can do that calling the has one. That means that this entity has one of the other entity types. So this speed one has one player, basically. And we need to also configure the relationship from the other point of view. So the speedrun entity has one player, while the player has many speedruns. And we do that calling the with many method, and pass an expression here that selects. Actually, no. Since there's no navigation property on the other end of the relationship, we don't need to pass any argument. With many, and then we need to specify the column that contributes as the foreign key. We do that by calling the hasForeignKey method. And here we pass the name of the column as a string, and I think it was player ID. Pretty sure it was player ID. We need to do the same thing for the game, so I just duplicate this row by pressing Control and D. And let's go here, say game with many hasForeignKey game ID. And this, in order for the speedrun to include its component, player, we need to also map the player entity to the database. So let's do that up here. Oops. There we go. Okay. Yeah, let's do the same old thing. To table, player entity, has key. Oops. ID, property, ID, has column name, ID, lots of IDs here, player entity, property, gamer tag, has column name, gamer tag. Did I forget something? I feel like I forgot something. Yeah, there's one thing. I don't have to do that, but if I want to be thorough, then I should do it. There's a method called hasAlternateKey, and this is to specify that there is a unique constraint on one or multiple columns. And if you remember, we actually created a unique constraint for the player, for the gamer tag. So we're going to say that the gamer tag is the alternate key. Okay, that should be it. Okay, so we mapped all of our models to the database, so that's fine. What I want to demonstrate now is there's one more thing that we need to actually do. But let me quickly demonstrate. Let's create a another unit test. What's wrong? Add class. Okay. I think my laptop is acting up. Okay. Speedrun repository test. It's a test class. This is in a different namespace. Get Speedruns test method. We don't need to specify a category. We could do that, but we have 2 unit test classes so far, so we don't need to actually put them into any categories. Okay, so let's do the same old thing. Speedrun, what was it called again? Speedrun database context. There we go. Let's call it context. Create an instance of it. Then create a speedrun repository, which is in a different namespace. Let's just call it repo. Pass the context to the constructor, then get an enumeration of speedruns, which is again in a different namespace that we haven't included yet. There we go. Speedruns equals repo.getItems. So now this will work. sort of. Actually, it does exactly what it's supposed to do, but you will notice something quote-unquote curious. Let's first assert is true. Oh, sorry. Speedruns. Hey. Is not null and speedruns any. I mean, this is not technically not an accurate check for the success of the test, because if there are no speedruns in the database and this does not retrieve anything, it was actually successful, because there was nothing in the database and it retrieved nothing, so it did exactly what it was supposed to do. But since we know that there will be speedruns in the database, we just say that if it doesn't retrieve any, something must have gone wrong. Okay. Now, I'm just going to make a point here. Let's debug this, and you will notice something that you may or may not expect. Let's see. If you've worked with entity before and know about the object graph and stuff like that, then you will know. But let me show you. Okay, so now we actually retrieved our 4 speedrun objects from the database. Hey, it looks great. But let's actually inspect them. Let's look at the first entry. Game is null. Player is null. Why is that? We didn't set them null in the database. It doesn't make sense. Well, the explanation is quite simple. Entity doesn't by default load the complete object graph of the entity, meaning all of its sub objects, all of its components, and their respective components again and again. It doesn't recursively do that, because just because we want to get the speedrun instance from the database doesn't inherently mean that we want to get the entire graph. Maybe all we need is the ID and the record date and the time. Maybe we don't care about the player in the game, and so entity really just does what it needs to do, and it doesn't load the full object graph. Basically just returns the base object, but we can tell entity to include these navigation properties as an actual instance of the respective entity. Excuse me. Yeah, we can do that. So for now, the test is successful. That's great. Let's go into the repository. And actually, let's not make this an expression body. Use block body for method. There we go. Whoops. And now we need to tell entity what navigation properties to include in the object graph. And we can do that by simply calling the include method, which is in a different namespace, in the Microsoft Entity Framework core namespace. There we go. It is an extension method. Include, and then we can pass an expression there that points at the navigation property that we would like to include, which is both the game and the player. So we just chain call include for both of the properties. There we go. And now we convert this to a list, and that's it. And we need to do the same thing when we only retrieve one instance. Did I mess something up? All right. After we call the include method, include returns an includable queryable, which is basically, yeah, as the name says, a queryable collection, an interface for that. The find method is a method of the dbset class. It's not a method in the includable queryable interface, so we can't use the find method here. But as I told you earlier, we can simply use the link extension method first or default, which returns the first instance where the predicate that I passed to it returns true, or default, which would be null in case none of them match the predicate that I pass. So we just basically match against the ID. Yeah, and that's it. So now if we run our test again, we should see that the complete object graph has been loaded. Hopefully. Yeah, there we go. We have a speedrun object, and it includes a game, Super Mario World, and it includes a reference to the player, Lucky Goodrich 90, with ID number 1, of course. Yeah, that's it. It works. And so really all our domain service needs to do is call that repository method get items. That's, I mean, at this point, that's all we want to do. Later on, we should actually query the data, like make it possible so that the client who calls the web service can specify what data specifically they want to retrieve, like only, I don't know, only get speedruns for games published by Nintendo or something like that. But for now, all we want to do is retrieve all of the speedruns and return them to the client as a response of the web service. Okay. So let's go get started in our service layer here and implement a method that does exactly that.